So hey, hi everyone. This is Devansh here, and today we are going to discuss the beautiful problems of today's biweekly contest 178. So this is by TLE Eliminators. So hope it was a good contest for everyone. And today we are going to discuss all four problems of the contest. Do comment out how many problems you all did in the comment section. And during this post contest discussion, if you guys have any doubt regarding any contest or any problem or any section of the post contest discussion or any part, you can just ping it out in the comments. I will be actively watching comments even after the contest. So first let's start. Everyone do ping out how many questions you did in today's contest. So today's contest was a beautiful contest. The first three problems were on a easy side, and I think the fourth problem was a good problem. It was more of an implementation problem, but yeah, it was a good problem. So yeah, let's start with the very first question. So yeah, first unique, how are we going to solve the problem? First we are going to discuss about entire problem, and we will get as much as we can from the problem statement and the examples, and then we will move towards the intuitions and observation we could make from the problem statement itself. And then the third part, which is our solution part, we'll discuss how can we reach towards the solution using these intuitions and observations. And also we are going to see my own code, so we can take reference from it how I implemented it. So yeah, let's start one by one. First, unique event element. You are given an integer array nums and return an integer denoting first even integer earliest by array index that appears exactly once in nums. If no such integer exists, return -1. An integer x is considered even if it's divisible by 2. So it's like a classic first problem of Leetcode. It's pretty easy. Yeah, let's start. So this is our first problem, right? So what we are told, we are given this nums array, and what we need to find, first occurrence of even integer which has one frequency, right? One frequency, or which occurs only one time in entire array, right? So this is our problem. How can we deal with it? There are plenty of ways to deal with it. Let's also see the constraints of the problem. So here we are. The length of nums is less than 100, and for each element it could be from 1 to 100, right? So let's make it here. Let n be the length of the array. So n here is less than equal to 100, and obviously it's greater than equal to 1, and also num size is less than equal to 100. So this is our entire problem here. And now what we have to do is, basically this is just an implementation problem, right? How can we implement this? So it's pretty easy. First also let's see some example. What does this problem statement mean? So let's say we are given this array, the example array. So yeah, so let's say we are given this array, then what would be our answer? What do we need? We need first occurrence of even integer which has one frequency or which occurs only one time. So yeah, let's start. We need first occurrence. That means we will need to start from the left side, right? So when we start from the left side, this is our first thing that we need to start from the left side. First observation. So if we start from here, is it even? No, it's not even. Is it even? Yeah, it's even. Does it occur only once? No, we also have one more 4 here, right? So no, this is not our answer. So everywhere we have to check two conditions. Is it even? And it has only one occurrence. Right. And similarly we can check for here. Is it even? Yeah, this is even. Does it has only one occurrence? One occurrence? Yeah, it has only one occurrence, so this is our answer. So we are going to return 2 here. Let's take one more example. Let's say we are given this 8, 4. Right. We'll start from the left side. Is it even? Yeah, this is even. Does it occur only once? One occurrence? Yeah, we have only one occurrence, so this is our answer. Our answer is 8. Right. So we just need to implement it. There are plenty of ways to implement it, right? How are we going to implement it? There are plenty of ways to implement it. One of them is basically we can do the brute force. We know that we need to start from left side, right? And then we need to find if it's check both conditions. If it's even, we can easily check it, right? We can basically do its modulo 2 and see if it's 0 or if it's 1. If it's 0, that means it's even. That means when we are dividing it by 2, it does not leave any remainder, right? Basic maths. And second, we need to find occurrence. We have two ways. We could either store the occurrence somewhere, store the occurrence in a dictionary or in a map, right? And we could check here. Let's say we make a map MP or dictionary MP, right? We could check if MP of this nums I, if the total frequency of this is equal to 1. And if we both are true, we are going to return it. Otherwise, we can also check for all the elements. Again, we can do one more loop here. Check all elements. Our constraint allow us for both the parts. Like we are comfortable for both the parts. Here we are basically going to run one more for loop that's going to check for all elements from 0 to I minus 1. And then I plus 1 to n, because this I is already present here, right? And we can actually check this frequency count here, right? We can actually iterate entire array and check this frequency count here and check what's its frequency, and if this frequency is equal to 1, that means the answer is like this condition is true, right? So this is our condition. Right, so this is our entire algorithm for the problem. Hope you guys got it. Hope this crystal clear. This was very easy problem, and now let's actually see our code, how I implemented it. So yeah, so this is the code. If you guys think there is any more further interesting thing you guys want to add, you can actually ping it out in the comments. I will be actively watching comments, and if like you think you have any queries also, you can actually ping it out. I will respond to it. So yeah, so this is actually what I did was I actually stored all the I'm basically stored all the occurrences. So here I'm storing the frequencies, and here I'm just checking both the conditions. This check if its frequency is 1, and this check if it's even. And if it's right, then we are going to return this. And if both are not true, that means there are no such elements, right? For example, we have some array like 3, 1, 7, right? The answer would be -1 because we don't have any even, right? It will fail, and it will never have this even case, right? So we are going to return -1 here. So if there are no cases, there is no answer, we are going to return -1, right? So this is my entire answer. I hope you guys got it, because this was actually very basic problem, like typical lead code contest first question, right? Let's move towards the second question now. Yeah, hope you guys got it. Yeah, so sum of GCD of formed pairs. You are given an integer array nums of length n. Okay, construct this prefix GCD where for each index I, mxi is equal to max of num0 num1 num dot nums I. Basically the maximum element in this up till ith index, or up till the prefix I. Then prefix GCD I is equal to GCD of nums I into max I. Got it? So what we are told, let's do point by point. We are given this nums array which has size n. Second thing we are given is we need to first find this prefix GCD, and for it what we need to find, we have this max I. Max I is max of all the elements starting from nums0 dot all elements in the prefix, or all elements up till the index I, max of this. And prefix GCD I is equal to GCD of this mxi, ith element of this array, comma nums I. Got it? So first we are given that we have this nums array of length n. Second, we are given that we need to find this prefix GCD array, right? Construct an array. After constructing it, sort this array, sort the prefix GCD array in non-decreasing order, that means in increasing order, and form pairs taking the smallest unpaired element and the largest unpaired element. Repeat this process until no pairs can be formed. For each pair, each formed pair, compute the GCD of two elements if n is odd. The middle element in the prefix array remains unpaired and should be ignored. Return an integer denoting the sum of GCD values of all formed pairs. So basically, when we need to second step is we need to construct this. Third, what we need to do, we need to follow some series of operation to this, which is first sort. The operations will be followed on this array. The first operation is we need to sort. Second is we need to form pairs. How pairs? Let's say this PCD prefix GCD array looks like this: A0, A1, A2, dot AN minus 1 and AN. We need to make pairs of the least element and the largest element here, and similarly for the next least element and the next largest element, right? We need to make pairs out of it. Then third thing, calculate GCD for each pair. For each pair. What does this mean? For this pair A0 AN, we will calculate the GCD of A0 AN. Similarly, we find GCD of A1 AN minus 1 and dot. Right, and the fourth thing we are given sum of GCDs. This is what we need to return. Right, this is our question, right? We need to basically add all these GCDs, and we have to return this. And if there is odd number, right, we are going to ignore the middle element. Let's say this is that means that let's say A0 A1 and A2. There are odd number of elements, so we'll make pair of this and we'll ignore this. Ignore. Right. So this is our entire question. Now let's also see its constraints. So n is less than equal to 10 raised to power 5 and num is less than equal to 10 raised to power 9. So let's actually place it here. N is less than equal to 1e5. I hope you all guys know 1e5 is equal to 10 raised to power 5. It's just how we denote it. And similarly nums I less than equal to 10 raised to power 9. Right. So this is the entire question. So basically this question was series of implementation. You just have to do what's already told in this question. Implementation. Right. You just have to do what's already told in the question. Just do what's told. Right. And you will arrive towards your answer. So let's do step by step. Let's see some example. Okay. 264. Let's say we are given 264. Our array is 264. Right, this is our nums array, right? Nums array, right? So what we need to do, let's do step by step what's already told. Okay, we'll just follow the steps. We'll just do what's told. First we need to construct this prefix GCD. Okay, great. So prefix GCD, ith element of prefix GCD array is going to be GCD of max I and nums I. Okay, great. So first step, construct prefix GCD. This prefix GCD. Okay, great. So the let this prefix GCD will be equal to A0, A1 and A2, right? It will have 3 elements, and here A0 will be equal to GCD of nums I is equal to 2, comma the maximum element in this prefix, as this prefix has only one element, 2, right? So this is nums I max element yet. Element yet means that we are starting from the left side, right? And the max mxi is also calculated from the left side. Max element or mx1, mxi, right? So A0 would be equal to GCD of both is 2. I hope you guys are already aware of GCD. GCD stands for greatest common divisor. It is basically the greatest number we could get that divides both A and B if we are calculating GCD for A and B. Similarly, A1 is going to be again GCD of nums I is again it's 6. Okay, and the maximum element we could find is also 6, right? So this is also this is going to result in 6, and A2 GCD would be around 4 because this is the element, right? Nums 0, nums 1, nums 2. Nums 0, nums 1, nums 2. Nums 2 is equal to 4. And the maximum element we could get is in the prefix is 6. As GCD is equal to 2. Right? So this is our final array. Yeah, there's like this one observation that the number of elements in prefix GCD is going to be same as number of elements in the initial array, right? Because we are basically finding prefix GCD for every element, right? Until of the size of our initial array. So this is equal to 262. Got it? So this is our first step, right? Yeah, we did it. What's next step? We are just going to do what's given in the problem statement, right? So now we are told we need to sort it. Okay, let's sort it. If we sort this is going to result in 2 2 6, right? Now let's go again. Let's see what's told. We just sorted it, right? We are just going to do what's already told. What's told. Now we are given to find the pairs, right? We need to make pairs of smallest and the highest element possible, starting from the very small. The smallest element is this, biggest element is this. We formed a pair. Got it. Third was pairs. So one pair is 2, 6. As this is odd element, we cannot form pair for this. So we are going to ignore this. So only pair we have is this. And next step we are told is calculate GCD for each pair. So we are going to calculate GCD for this. GCD for each pair. So GCD for 2, 6 is equal to 2. Right? Yeah. We only have one pair by the way here. And then sum of GCDs is our answer. The sum of GCDs here is 2. So this would be our answer. So yeah, we took the example and 2 is our answer. Hope you guys got the problem, right? We just need to follow this sequence. First we need to construct it, and then we need to sort it, then we need to find pairs, and then we need to find GCD for each pair, then we need to calculate the sum. So it's more like an implementation problem. So let's see how are we going to implement each part. For this part we can easily iterate from leftmost, and we'll keep on iterating towards the right. We'll keep a max element which will tell us the max element that occurred till yet, and we are just going to do GCD. GCD can already you can apply GCD using the built-in function in C++. We can type GCD, right? We can and then literally find GCD of 2 elements using this function. So this is how we're going to implement the first part, which is the construct prefix GCD part, constructing or making this array. Now comes the second part. This is again a cakewalk because we can just use the sort function here, right? Sort function is available in Python as well as in C++, right? Both have different implementation, different way of writing, different syntax. That's fine, but yeah, we can easily sort it, right? Finding pairs, we can keep one starting pointer that points towards the starting element, which is currently 0, and one that points towards the ending element, which is equal to n minus 1, which is n minus 1. N is our size, right, as we are doing 0 based indexing. And then we can keep a loop here, right, while starting is less than ending, and we can then make pair of 2 elements, right? We can keep one vector, and then let's say this is vector pair, and we can easily push here our pair, which would be prefix GCD of the element start, right, and prefix GCD of the end index. We are just going to push it, right? We are going to push this pair in our vector. So here we can easily make this pair, right? And for each pair we need to calculate GCD. So later we can just iterate each pair, and we can find GCD using this function GCD, right? which is like an inbuilt function. We don't even need to implement it. And the final is sum. We can easily calculate our sum using some answer or some variable here, right? So this was the entire. We just need to implement it, right? We just have to understand the problem and we just need to implement it. It's pretty easy problem. So let's see step by step how to do it. How I did it basically. So yeah, this is our new array, or this is our prefix GCD array, right? This is our max, which keeps the track of the maximum element. Also guys, no need to worry. This entire video as well as all the solutions will be provided to you, so no need to worry about it. And this here is just we are finding this line. This tells us how we are basically calculating our new array or constructing our prefix GCD array. And then here we sort it. Here we are just making pairs, and instead of making pairs I'm doing just I'm not even making pairs, I'm just calculating the GCD in one go. So after making pairs, what we need to do, we need to calculate GCD. So let's calculate GCD in this turn, right? And then we add it to our answer variable, and then we increment the st and we decrement the en pointer that points towards the vector, and then we return our answer. Hope this was super clear, and the code snippet, the code of this entire problem will be provided to you in the comment section, so don't worry about it. This is actually the code I wrote during the contest. The code I will provide in the comments would be much more, it would be of better quality with good comments and all, right? But yeah, it doesn't matter, right? We don't have to memorize anything. It was just an implementation problem. So yeah, I hope you guys got it. Let's move towards the third problem. The problem number C or the problem number third, right? Yeah. And if you guys have any doubt regarding this problem, you can always ping it out in the comments and reach out to us, right? Yeah, let's read the problem first. You are given two integer arrays, nums1 and nums2 of size n. You can perform the following two operations any number of times on these two arrays. Swap within the same array, choose two indices I and j, and then choose either to swap nums1 I and nums1 j, that is the ith and jth index, ith and jth elements of the nums1 array, or ith and jth elements of the nums2 array. This operation is free of charge, that is, this is not going to cost us anything. The cost of this operation is then therefore 0. Swap between two arrays, choose an index I and then swap nums1 and nums2 I. This operation incurs the cost of 1. Return an integer denoting the minimum cost to make both nums1 and nums2 identical. If it's not possible, return minus. Okay, great. What we are told? First we are told we are given two arrays. The name of array number 1 is nums1 and the name of array number 2 is nums2. Okay, great. Second is we are given two operations, right? The first operation is swap within an array. Right, and the second operation is swap ith index of both arrays, right? It's mentioned in the problem statement itself, right? So yeah, we are given two operations and we are given the cost of this is going to be 0 and cost of this operation is going to be 1, right? And third is the point that we need to do, that we need to find, which is minimum operations to make both identical. So yeah, this is the entire problem. Let's take some example here. Let's take this example. So basic. So this let's also see the constraints too. Yeah. So the length of both the arrays is 8 into 10 raised to power 4. Let the length be n, then it's less than equal to 8 into 10 raised to power 4. Okay. And also each element here, nums1i or nums2i, is 8 to 10 raised to power 4. Nums I, either it's 1 or nums2i. Both are less than equal to 8 into 10 raised to power 4. Right. So this is the flow of the problem. This is the entire problem. First we are given both the arrays, then we are told that we have two operations. The operation number 1 tells us that we could swap among two elements in the array itself, and the operation number 2 tells us the cost of this operation is 0, and the operation number 2 tells us that we can swap ith index of both arrays and its cost is going to be 1. The minimum number of the minimum operations we have is identical. That is, to make them identical, the minimum operations we need to make both arrays identical. We need to find this, and if we cannot, we have to return -1. And these are our constraints. That means we need to find it in n log n or n, right? I hope you guys know how to calculate constraints. If you guys don't, you can actually ping it out in the comments, and then we can set up some video regarding it, or you can send you some resources regarding it. And even if you guys need resource or for anything in the computer programming part or any part of the problem, anything you are not already aware of, you can actually ping it out in the comments. I'll provide you the link towards the resource. So yeah, let's move. This is the entire question, right? So let's take one example. So yeah, here's our example. Let's actually move it somewhere. Move it here. Yeah. So we are given two arrays, nums1 and nums2. Right. Now we are given operations, right? We can perform operations and we need to make them identical. Right. We have some operations here. Now what I can think of is that, like, it's pretty observational and like it's pretty obvious for this problem. Let me actually plug my laptop. Yeah, it's like pretty straight observation here is that I can make operation number 1 here and swap these two elements. After swapping these two elements, the array would be 20, 10, right? nums1. And what would be the cost of this is equal to 0, right? Cost. And in 0 cost, we need the minimum cost to make both identical, right? Minimum operations name, minimum cost, not the minimum operations. We need to find the minimum cost to make them identical. And yeah, so our answer would be 0 here, right? So yeah, let's talk more about the problem. First, let's talk when can we make both identical. When can we make both identical? When can we make both identical? So when we have even number of occurrences of each element in both arrays, right? This is the first observation. Even occurrences of element even occurrences in both arrays. What do I mean by this? Arrays. Like how come we come to this conclusion? Right? It's pretty obvious and observatory. I wouldn't say observational, but I would say this is pretty obvious here, because let's say we are given this array 20, 30, 20 and 40. Now this is nums1 and this is nums2, right? So it's more of a fact that if we want both identical, right, if we want any arrays identical, the first array would be like this and the second array would also be like this. That means that if this occur here, this element is here, the same element would also be here. The value of both the elements would be same, right? That means we have two occurrences here. Similarly, we would have this at least twice occurrence of each element, right, that we are having. And this problem, we have 30, we only have one occurrence. We have odd occurrences here, odd occurrences, and because it's odd, we cannot distribute among them, right? We cannot distribute among the first array and the second array, right? So this creates a problem for us, right? Thus we came to conclusion that even occurrences in both arrays of the element, right, even occurrences calculating in both arrays, right, the sum of occurrences of 20 in both arrays should be even. We have how many 20s? 1 and 2. We have two elements whose value is 20, and as we have two elements, which is 2 is an even number, it's fine to go, right? But 30, we only have one occurrence, right? Or we have odd number of occurrences. If we have odd number of occurrences, we cannot distribute it, right? We cannot distribute it evenly. So this is our first observation. What is second observation we can make from here? Let's say we have this array 20, 20 and n2 is n1 means nums1. I hope this is self-explanatory. And n2 means nums2. I have just written m1 and n2 for our for our convenience, and so it's easier to understand and it's less to type, right? So yeah, n1 is 20, 20 and n2 is 10, 10. Do we have even occurrences of all elements? So yeah, 20 is occurred twice, which is an even number in both the arrays, and simply 10 has occurred twice, which is an even number in both the arrays. Okay, well and good. So yeah, that means yes, answer exists. Are we sure about this? Yeah, right, because if we have even number of occurrences, we can distribute it eventually, right? The operations we have, we are told that we can swap among two elements in the element itself, and we can swap among both the arrays, right? So basically swap among the array across array. Yeah, I know we have mentioned that we can not swap across array, but we can swap ith index of both arrays. But can I say that we can actually swap any two elements? Can I say this means we can swap any two elements. We can swap any element, any two elements, right? How can we say that from this? Let's say we have this array A, B, C, and we have this D, E, F, right? This is just random like how we represent the array. This is our nums1 array and this is our nums2 array. Now let's say we need to swap this and this. Can we do it? Can we do it? Our first operation allows us to swap among the array. So we can swap these two elements. So this would become C B A D E, and this is D again, right? So yeah, and then we can swap ith index of the two arrays, right? So we can swap this. So this would become C B D D E A, and we can later on swap these two, and we could turn D B C D E A. So we have successfully swapped two numbers, right? A and D, right? So this was our journey. So this observation, this could be our second observation. Have we made any observation? Yeah, we have made one observation here. So this is our second observation, right? That we can rearrange all the elements any way we want, right? Because we can rearrange among ourselves in the R array itself, and then to basically exchange, we can exchange any element with any element, right? Because we can basically do this, right? We wanted to swap these two. What we did, we swapped these two in the array itself. As its cost is equal to 0, we can swap among the array as much times as we want, right? So this is what we did, and this is how we swap. So this comes to our second conclusion, that we can swap any two elements, right? Or we can rearrange as we want. We can rearrange elements as we want. Okay, so here we came to know that answers will always exist, because you can swap and we can rearrange all the elements in both the arrays, right? Because if we can swap any two arrays, we can rearrange them as many times or as many variations we want, right? So yeah, coming on to next point. Okay, we can swap any two elements, we can get the array. How are we going to get it in minimum operations? So this is our question, right? Minimum operations. Okay, let's think one more thing. Only operation 2 has a cost, right? Operation 2 has a cost. Yeah, it has a cost. The cost is equal to 1. If we minimize the number of operations of 2, we can get our answer then. Then we will get our answer, because the only operation which is going to cost us is operation 2. That means that we have to limit its number, right? We have to limit the number of swaps between the array, between two arrays, which is nums1 and nums2 respectively. Okay, got it. We need to minimize operation 2. So how are we going to find the answer? Let's say we are given this. Right. This is a nums1, this is a nums2. Let's check our condition. The first condition is all the elements should have even number of occurrences. Yeah, they have. 20 is twice, which is even. 30 is twice, 40 is twice. Got it. Okay, great. Now we need to swap two elements, right? And then we need to basically make them identical. That means I need 40 here, right? I need 40 here. Got it. If I move 40 here, this 30 will be here, right? And then we have to make one more swap accordingly, right? There is one observation that you have to make. Let's say we swap these two. We just observed here that we can swap any two elements, right? And the cost of it is always going to be 1, right? Because you can swap it here and then we can swap it here, right? So the operation 2 will only be called once, right? Just 1 second. So basically the operation 2 will only be called once or only be used once. That means the cost of this is going to be 1, right, when we swap any two elements across the board. So let's say we did this, the cost is going to be 1, and yeah, we would be able to swap them. So we will get 40 here, we will get 30 here. Now we have 30 here and 40 here. So yeah, now we need to swap again, right? We maybe need to swap these two, so these two become identical, and we can again swap. We can do 30 here, we can do 30 here. This swap would make 20 20, 40 40, and yeah, we made it. So this is one of the this will again cost 1, right? So this costs us, the total cost was going to be 2. Is it the answer? Is it the most effective way? We let's find out actually. Or like there is one more observation we can make. We just have to make both array must have all the numbers, all required numbers, all elements, whatever we want to say. So basically this tells us that if both the arrays have all the numbers, we can rearrange it. Is this point true? Yes, right. Let's say we have 20 20 30 30 and 40 and 40. We know that we have two occurrences of 20, two occurrences of 30, and two occurrences of 40. That means the final array would look like this: 20 and then 20 here, 120 here, 120 here, then 30 here, 30 here, then 40 here, 40 here. Will look something like this, right? So we can say occurrence of each element divided by 2 will be in A and similarly in B. That is occurrences, or let's call it frequency, right? Frequency of each element divided by 2 would be in A as well as in B. Can we say this? Yeah. Surely we can say this. The frequency of each element, the frequency of 20 is 2. That means divided by 2 would be here and here. We will divide its frequency by half, right? Because we need it common here and here, right? Thus frequency of each element, right, should be equal in both arrays. Frequency of each element should be equal. Let's say we had this 20 30 and 40 and 40 20 and 30, right? How much cost would it take to make them identical? We know that we have all the elements 20 30 and 40 here, right? And we all have 20 30 and 40 here, right? For each element these two conditions have satisfied, right? That is, frequency of each element is equal, right? We have 120 here, 120 here, we have 130 here, 130 here, we have 140 here and 140 here. Now swapping among the elements, we can create any permutation, right? Swapping two elements in an array any number of times. Why any number of times? Because cost is equal to 0, right? Swapping two elements in the array or operation 1, right, cost is equal to 0, can help us rearrange this element into any permutation we want. Rearrange into any permutation. right? We can rearrange this array into any permutation we want. That says that we can rearrange it into this permutation if we have equal number of elements for each. Because if we want to rearrange it, let's say we start rearranging it, we would require 140. We'll take 140 from here, we'll place it here. We'll require 120, we'll place it here. And we'll require 130, we'll place it here. So yeah, as we had equal number of elements for each element, so this would be our answer, and its cost is going to be 0. Right? That means that we just need to divide the frequency of each element evenly in both the arrays, and that's all the work we need to do, because that's going to cost us 1. Right? Its cost is going to be 1 unit. Okay, got it. So we formalize the problem into distribute each element equally. Right, we just need to distribute each element equally. Okay, got it. So how are we going to distribute it? Now, using minimum operations. Right, let's analyze how can we move from here. Let's say we are given 20, 30, 20, 30, 40 and 40. Right, let's make a frequency. Let's count frequency for each element here. Right, so 20, 30, let's make a frequency table. The number of, how many occurrences of 20 we have? 2. How many occurrences of 32? How many occurrences of 42? For any element we would require half in nums1 and half in nums2. That means 1 in nums2, 1 occurrence of this, 1 occurrence of this and 1 occurrence of this. Okay, got it. We need all these 3 in both the arrays. Do we have 20 here? Yeah, we have 20. Do we have 30? Do we have 30? Yeah. Do we have 40? Oh no, we don't have. Got it. So 40 is here is missing. Similarly here, do we have 20? No, we don't have 20. But we have 30 and 40. Right. So number of elements missing from here is 1. Number of elements missing from here is 1. Right. Can we exchange it now? So this is a final and master observation. Exchange them. What would be its cost? Its cost is going to be, the total cost it will cost us is going to be 1, or the number of elements to exchange. Because in one exchange we can exchange 1 pair. So we can basically exchange them. So here after exchanging them, both the arrays would be 20, 30, 40, 30, 40 and 20. Now as we can do as many number of, we can make this array to a, we can arrange it at any permutation as we want using operation 1. Right, we can arrange it to make it identical to the second array. So we can make it 30, 40 and 20. Right, the only cost it costs was to make exchanges, right? Number of elements we have to exchange. Got it. So this creates our algorithm. The entire problem is divided and dissected, and the final crux of the problem is this. First thing we need is, we need to distribute each element equally. This is the first thing. And then second thing is, we need to exchange them. Right, if we did these two operations, we'll reach to our answer. Right, so this was the entire problem. Right, we started here and we ended here. Right, so basically implementation part. Right, we just need to implement this. First we need to distribute it. We can keep a frequency or a map. Right, our dictionary, we can use that to calculate frequency of each element, and then we can determine the needed frequency for every element, and then we can find it out. Right, I did it in bit, like the approach I used is bit complex. Right, but yeah, let's see it. So first I calculate the frequency of every element in M1 and M2. Right, M1 is this helps us to calculate frequency of each element in nums 1 and nums 2 respectively. Right, here we calculate our frequency. And now we come to this part. Here what I'm doing is, let's say take this array, right? Now we have 20, 30, 20, 30, 40 and 40. Right, the order doesn't matter. Now M1 map would have 20 and its frequency which is equal to 1, 30 and its frequency equal to 2. M2 would have its numbers, right, its elements, right, 30 and its frequency is equal to 1, 40 and its frequency is equal to 2. Now we want all the elements equally distributed, right? That means if this its frequency of every element here and here should be true, right? M1 tells us frequency of each element in nums 1 and this tells us frequency of each element in nums 2. Frequency of each element in nums 1 and 2, 1 and nums 2. Right, so yeah, using this, what I'm doing is I'm just iterating over every element here. I'm iterating 20 and I'm seeking if the number of 20s here is 2 and this is 1, right? My bad. We are seeing if its frequency here is equal or not. It's not equal. We have 2 and we have 0 here, right? For element 20 we have 2 occurrences here and 0 here. So what I'm going to do is I'm going to basically do exchanges here. How many exchanges are required to basically make it even? We need one exchange here, right? We need to put one element here to here, right? So I'm using this, I'm calculating this. How many operation do we need, right? We need to send one element over there. This is, I'm storing this in, I think Cn, right? This total count or Cn. This is, I'm storing it here, right? And for every element I'm calculating it. For 30 we have one occurrence here and we have one occurrence here. So both are equal, we'll do nothing. But for 40, now this we have successfully iterated it. And as we have already calculated for 20 and 30, I remove 20 and 30 from here, right? From the frequency of the second element. Why? Because now I'm iterating it here and I need fresh elements. Now for 40, I know we have 0 here and 2 elements here. That means we need to transfer their difference divided by 2 here. So this difference divided by 2 is added into Cn in each step, right? Plus equal to difference divided by 2. And a simple observation here is, if this difference is odd, right, that means we have to return -1 and there is no answer. Why? Let's say we have this 30, 30, 30 and 40. Here M1 would be equal to 30 equal to 3 and M2 would be equal to 30 equal to 1 and 30 equal to 2 here actually, and 40 equal to 0, 40 equal to 1. 40 would not be even here. So like we will iterate from 30, we'll see 2 here, we'll see 1 here, but we can never make both equal anyways, right? We can never make both equal. And if its difference is odd, that means its sum is also odd. Difference and sum of both elements have same parity. right? So this is a mathematical property. The difference and sum would have same parity, and we need the sum, which is sum is again occurrences of that element, right? And we need it even. So if it's odd, we are going to return -1. So here that's what I'm doing. This is I'm iterating m1, this is I'm going to iterate m2. Again this we are adding the absolute difference among them divided by 2, and if that absolute difference is odd, we are going to return -1. And we are, as we have already calculated for this element, I'm going to delete it from the map m2. And if it's not present in m2, that means we have all the occurrences in m1. So we are doing just the same thing, right? This -0 it would be, right? This mp, if I do it for dot first, I'm just doing it because if I do this, it's going to register it in it dot first into m1, right? That would create problem for me. That's why I did it in simple manner. So this is how I implemented, and I finally returned cn -2 because let's say in this operation we required one element to pass here and one element to pass here, and as we have swap available, we can do both operations in one unit, right? That's why we do finally cn divided by 2. So yeah, this was entire problem number 3. I hope you guys love the explanation. If you think if you have any feedback, you can actually ping it out in the comments. You can actually ping me personally too, right? If you think it's something personal. Yeah, but yeah, constructive criticism is always motivated and appreciated. So I think until this question, third question, the contest was pretty easy. The fourth question was on the other side, the tough one, and actually a very good question too. So yeah, let's discuss the fourth and the final problem. So you are given two integers L and R, right? An integer is called good if its digits form a strict monotone sequence, meaning the digits are strictly increasing or strictly decreasing. All single digit integers are considered good. Okay, let's start here. Our final problem, D, or the fourth problem. First thing, we are given two integers L and R. Second thing, we are told an integer is good if all digits are strictly increasing or decreasing, or monotonic. Strictly increasing or decreasing. For example, 89, the first digit is 8 and the second digit is 9. Similarly, 2375 to 2378 actually. Here 2, 3, 7 and 8, all elements are increasing, right? You can also do in decreasing manner, and also we are told all the single digit numbers like 8, 2, 4, they are good, right? Because there are only single integers left. So third thing we are given is an integer is called fancy if it's good or its sum of digit is good. We are given definition of fancy. So just 1 second. Yeah, so if it's fancy, an integer is called fancy if it's good or sum of digits is good. For example, 132. This is not monotonic, right? Or this is not good, right? Why? Because it's not strictly, its digits are not strictly increasing and decreasing. It's 1, it's 3, it's 2. 3 is greater than all both the elements, right? So it's not monotonic, it's not good. But it's sum. Sum is equal to 3, 1 plus 3 plus 2. It's 6. And 6 is a single digit element, so it's good. That means it's fancy. Right, this is what we are told. Return an integer representing the number of fancy integers in the range L to R. Okay. So, return number of elements in the range starting from L to R, right, which are fancy. This is what we are told. This is actually very beautiful problem. We'll see like how are we going to solve it. Do ping out how did you guys solve it actually, right? So yeah, pretty simple problem, like, right? This is just the definition of strictly increasing and strictly decreasing. So this is the entire problem. We are given two integers L and R. We are given, if you have reached till here, it's actually, I'll appreciate you that you have reached towards the final problem of the today's contest, right? So we are given two integers, integer L and integer R, and we need to find, we are given two definitions, definition of good and definition of fancy. Definition of good, an integer or number is good if its digits are strictly increasing or strictly decreasing order. Just like this, it's strictly increasing in 89, right? Because we have two digits, 8 and 9, and 9 is greater than 8, right? Similarly here we saw it. Now we are given one more definition, fancy. A number is called fancy if either that number is good, either sum of digits is good, right? That means sum of all the digits in it is good, just as we saw for 132. Okay, great. Now then we have to return all the return the number of elements such that from the range L to R which are good. This is what we have to return. Okay, great. So how are we going to solve it? Right. Let's first take some example. The very first example, let's take this one. Let's enlarge it. Okay. So from L to R, how many elements we have? We have 8, we have 9, we have 10. Right. Is it fancy? We have to find number of elements which are fancy, right? Is it fancy? Yeah, this is fancy. Why? Because this is good. Is it good? Yeah, this is good. Is it good? Yeah, this is good. That means we have 3 elements which are fancy as well as good. So 3 is our answer. Right? Right, guys. Similarly, let's take some another example. You only have one element here, right? Okay. Let's take this example. So let's see this example too. Now here we have two elements in the range. One is 1, 2, 3, 4, 0, and another is 1, 2, 3, 4, 1. And let's check this if it's good or not. Is it good? 1, yeah, 2 is greater, then 3 is greater, then 4 is greater, but 0 is less. That means it's not monotonically increasing. Increasing not. Is it decreasing? Not. Right, that means it's not good. Right, but we don't need to find good, we need to find fancy, and we have one more condition to check if a number is fancy, if its sum of digits is good. What is sum of digits of it? So this would be 1 plus 2 plus 3 plus 4. This is 10. right? And 10 is good. That means yes, it's fancy. Not by first condition, but by second condition. Okay, let's check for this element. 1 is less than 2, is less than 3, then it's also less than 4, but it's greater than 1. So it's not monotonically increasing, strictly increasing, right? Also, like, do note, we need strictly increasing. That means they cannot even be equal, and it's also not decreasing. Okay, that means it's not good. Let's check the second condition. This was the first condition. Checking the second condition, sum of them, 1 plus 2 plus 3 plus 4 plus 1, its sum is equal to 11. Is it good? No. Why? Because 1 is equal to 1. It's not monotonically strictly increasing and strictly decreasing. Again, right, not strictly increasing or decreasing. Right, that means it's not fancy and will return a final answer 1 here. Does 1 exist here? Let's see, is 1 on output? Yeah, got it. They have also explained it here in the explanation section. Okay, so how are we going to solve this? Right, before we solve, let's actually see the constraint of the problem. The constraint is ln r is less than equal to 10 raised to power 15. Where should we place the constraint? Let's place it here. That L comma R is less than equal to 10 raised to power 15 and greater than equal to 1. Right. So, like, for smaller constraint, this is like a pretty easy problem, right? How are we going to solve it if time or constraints are not the problem? Like, that way of solving is called brute force technique, right? What would be the brute force solution for it? Basically, check for each element. Check for each element, right? We would check for each element, right? If it's good or if its sum of digits are good. But as the constraints L comma R is less than equal to 10 raised to power 15, we cannot apply it, right? It will give time limit exceeded because we have a large number of large numbers to check, right? Pretty large range, right? So if you think of it, right, let's say we have this number 12 and we have 4 8 3 7, right? That means that we need some number. Let's say this is our L and this is our R. We need some number in between this, between L and R, right? This is our number that we need. Right, that is either strictly increasing by its digit or decreasing by its digits, or its sum is strictly increasing or decreasing, right? Let's so this is what we need to find. Okay, got that. So basically we have two conditions for each problem. Either it's strictly increasing and decreasing, or its sum is strictly increasing decreasing, right? So this problem can easily be depicted using dynamic programming. Right, let's observe some combinatorics here. Right, let's say, and combinatorics basically, let's say we have 12 4 8 3 7, right? That means at max we will have 4 digits to cover: digit 1, digit 2, digit 3, digit 4, right? And if for this we have 4 options, 0 1 2 3 and 4, we cannot place 5 here, because if we place 5 here, this entire number, it will have 3 digits. Later on this would be greater than R and we'll lose, right? But we can keep these many numbers, right? And if we like will keep on going, right, this is like This is like pretty standard problem, right? If we see in this way, not the standard problem actually, but pretty standard maths or pretty standard combinatorics, right? That we need to find something in range L and R, right? Let's actually think in these lines. So basically, for we have some number of digits, and we need to fill this such that the number is less than L, greater than equal to L and less than equal to R, right? And finally, we would require if that number that we have created is good, or the sum of digits of that number is good or not. Finally, we check this condition for the number, and what we need is basically to check how many numbers can we form. There could be very large numbers, the very large number of numbers, right? Because L and R is to 10 raised to power 15, right? But if we do like this using constraints, we might be able to conclude it in less and complexity, or we could solve it even faster, because this won't work, right? Doing it brute force. Okay, let's take in these lines. Yeah, we can make you can choose any number from 0 to 4 here. If we have choose 0 here, again we can choose any number here, 0 to 9, 8 and 9. But if our first element is 4, we cannot place 9, right? Because 4 9 x is again greater than r, right? This is our first observation, that we can actually take all the numbers, what numbers we can form, right? And the second observation is this, that we would need to make sure what previous number it was, because if the previous number was 4 here, we cannot place 9 here, because this would exceed our limit, right? So what I thought was, can I use combinatorics to basically solve what numbers I could get? I know if the range is from L to R, we would have 4 digits here, right? Yeah, the number could be 113, that means the first digit was 0, right? I just need to fill these 4 digits, right? Fill these 4 digits to make sure the number we get is greater than equal to L and less than equal to R. And then finally I do 2 conditions check. The first is if it's good, right? Otherwise, if sum of digits is good. Right. So this was my entire thinking, right? That helped me to solve the problem. So let's actually start. The first observation is, let's see for combinatorics. The second is, this is our problem statement. This is what we want to achieve. Okay, great. Yeah, if it's 4, then we cannot place 9 here. And now again, for this is for second digit, right? This digit we'll have total 4 digits. Now for third digit, this one, again we can place from 0 to 9. But if these two are 0, then we cannot place 0 here. Why? Because this would be 0 0 0, and this would be any number x. This is less than L, because L is equal to 12 here, right? Because this is twice, it has 2 digits, it has 1, it will be always be less, right? That means we have to take care of boundaries while forming it. And at last, when we reach here, we could keep its sum, right? And we could also check while we were choosing it, if the number we are choosing is strictly greater or strictly let's say decreasing or strictly increasing. And similarly, we would know if it's strictly increasing, strictly decreasing, and we would also have its sum, and we could check from here if this is true, or if this is good or not. And then using this, we can tell we can tell if this number is fancy or not, right? And similarly we can check all the elements from L to R, right? Let's check it in more depth, right? So basically what I'm doing is, first I'm seeing how many digits can we make. That would be equal to the largest number, how many digits it has. And second, we try to make all the numbers 0 to 9 and see what numbers can we make and what numbers we cannot. And we have to make sure of the boundaries, right? Because if the previous elements are tending to be equal to L or tending to be equal to R, then we need to check, because this 4 was tending to equal to R because this was in this form, 4x x x, and we are in this position. And similarly our R is 4 8 3 7, and if this and this element, they both are tending to this element, its prefix element or the element previously we have chosen is tending to be equal to R. ठीक है? Okay, so previous elements looks like R or even L, right? These are cases that we need to handle, right? That similar case took place here, right? Both digits were 0, right? And now we have to choose the third digit. And similarly in L, both digits are 0, right? Now this element that we have to choose has to be greater than 0, greater than equal to 1, because here the element is 1 and here the element is 2. This has to be greater than equal to 1, otherwise this element would be less than L. And this we don't want, right? So we have to take care of this condition, right? Let's do step by step what we have figured out. First, that we can figure out that we have to fill some digits. Digit filling. Digit filling. Let's say again L is equal to 12, R is equal to 4837. The digit filling tells us that we would have 4 digits and we need to fill this. Second is constraint of L and R. L and R. If the previous elements are equal to L or R, right, then we have to take careful considerations of what element we could choose. Carefully choose elements. This is our second constraint. Third is that we need to basically take a sum variable to calculate sum of all the elements we are taking. And fourth, we need to find if it's strictly increasing or decreasing. Right. And similarly, the main idea is we need to basically find for all elements, all possible numbers. Find for all possible numbers, right? So we can make a DP out of it, right? And the DP would include first the digit we are on, right? Let's actually talk about the DP states we have to make using this. The first state would tell us the digit we have to fill. The second state would tell us the previous element. Previous element is very important, right? Because this we need to calculate to check if it's strictly increasing or strictly decreasing, right? If the current state is strictly increasing or strictly decreasing, right? And third, what we could do is, what I did was, instead of calculating what state if it's strictly increasing or strictly decreasing, I broke the problem into two parts. You can also do it for explanatory purpose later on. Yeah, you can, if you are if you completely understood the problem, you can apply it by yourself, right? But initially we are going to understand from beginner's perspective. The beginner's perspective, let's break this problem into two parts. First, if all the elements are strictly increasing, and then we'll check for strictly decreasing part. So this third variable was a sum, right? Sum. What is the maximum value of sum? At maximum, r is less than equal to 10 raised to power 15. That means there would be 15 digits, and each digit is at max 9. So this would be 15 into 9, or even 150. Right, this would be 141 to be precise, but yeah, around this range. Okay, this would be around 15. Previous element can be max 9, right? And then our fourth thing, the boundary condition. We need to check if the previous elements that we have chosen are same as of L or R, right? For this, what I did was, if at this index 0, that means it's none. The previous elements don't match. Right, if it's 1, it matches with L. And if it matches with L, we have to carefully choose what element we can put, right? And if it matches with R, again we have to carefully choose with R, and the third condition, it matches with both. I hope you got the crux of the problem, right? The crux of the problem is that we need to find all possible elements, right? That is basically that are good, or if its sum of digits are good. And to use it, we are using dynamic programming. Why dynamic programming? Because we could just check for every possible digit what elements we could put it here, and then we could basically optimize it using the overlapping digits. Otherwise we have to check for each digit, and that's actually not going to pass, because it would take a great amount of time. We would have to edit till 10 raised to power 15 elements, right? We have to check for each element. That's actually too much of it all. But if we using dynamic programming, we would actually optimize. We are super fast because we are not calculating the overlapping part again and again, right? That's the prerequisite of the problem is that you are very good with DP. If you are not aware what dynamic programming is, do bring it out in the comments. We'll share the resources, or you can check the channel TLE Eliminators for the resources. Hope that's good. Yeah. So basically, we are going going on the DP mode. So yeah, we are going beginner. We are checking the beginner friendly approach, right? So yeah, we broke the problem into two parts. Let's check for strictly increasing, and then we could check for strictly decreasing, and then we'll add it. How's that? That's cool, right? So yeah, we started. This tells us what digit, what index we are filling. This tells us the previous element we took. This tells us the current sum. This tells us the boundary conditions. The boundary condition is 0. That means the previous doesn't match. That means we can take any element from 0 to 9 in this. Otherwise, if it matches with L, for example, our current element is 0, 0, and L is equal to 12, right? So L is equal to 0, 0, 1, 2. So, and we are choosing this element, right? Then this element has to be greater than equal to 1. So we'll have to start from 1 to ... 9. And similarly here, the statement changes. Let's say the number is 48. X, this is what we are calculating, and R is equal to 4832. Now, we have the previous element matches with R. That means these both matches. Then this element X has to be less than equal to 3. That means we can only put 0, 1, 2 and 3 here, right, in this digits place. And if it matches with both, okay, that means let's say if L is equal to 1 2 2 and R is equal to 1 2 3, that means, and let's say we have 1 2 and X, this is what we need to calculate. Now we have both the upper bound as well as the lower bound, that is X has to be greater than equal to 2, less than equal to 3. That means we have 2 comma 3, we have only two choices to fill this digit, right. So this we got from our boundary. This we check if still if condition satisfied. While picking numbers, is our condition satisfied or not, or the only condition we are checking here is strictly increasing for now. If it's strictly increasing, right, so we basically do this, and then we can also take this str. Just 1 second. Yeah, this is our entire problem. Right. Also, the sum is max 10. The sum is max 150. The boundary conditions can be 0, 1, 2 and 3. So this is at max 4 elements here. This is at max 10 because we are starting from 0 to 9, right. I can be at max 15 to 16 to 17, right, max, just taking good values so it passes. It doesn't create problem for us. And if it's strictly increasing or not, this is 0 comma 1. And what this str does is, let's actually understand it using the code itself. Let me show you the code. Code is actually pretty big. Let's remove this. Yeah, let's also remove this. This str basically tells us if we have chosen our first element or not, right. If we have chosen first element or not. How is this going to help us? Let me tell you. Let's take we are currently doing for strictly increasing. What would be the previous element when we enter? It should be -1, right. When we fill the first index, our previous element should be -1, right. And until we have filled our first element, it should always be -1. We can never put 0 here, right, because if we put our first element as 0, then if we take even 0 here, if our first element is even 0, right, then 0 is equal to 0, so it is not strictly increasing. It will mark it as not strictly increasing, right, and this will create problems for us. Got it? When we are going to fill, let's say we have 3 digits, right, we start from here, our previous element is -1, then we can choose all the elements from 0, 1, 2, 3. Let's say this previous would be used to check if we are still strictly increasing or not, right. If we choose -1 here, 0 here, let's say we are choosing 0 here, that means we still haven't choose our first element yet. This, as it's the initial 0, right, it's going to be trimmed out and we'll start the element from here. And this, let's say if this is 1, then it will not mark like this could be 0 or 1 again, right, dot, right. Again, if this is 0, if we take 0 and 0, these both are equal, but so it will mark that this is not strictly increasing, right. But this is indeed strictly increasing, as they both zeros are the zeros in the front of the number, we don't have to consider them in our strictly increasing and strictly decreasing debate. Got it? That's why we are using str. This tells us if we have already used our first element or not, right? Using this dynamic programming, we can easily calculate, right? Because sum is this, and later on, like what I'm doing is, for each sum from 0 to dot 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 150, I'm storing this in a different dp, or sorry, in a different array. It doesn't matter. I'm calling it def is predefined or defined, right? It's just my naming convention. You don't have to worry about it. This tells us this pre-calculates for all sum. For all possible sum. Got it? Because the all possible sums are from 0 to 150, right? We do only have these many choices that we need to pre-calculate, right? So using this states and this dynamic programming, we can check for strictly increasing and then for strictly decreasing, right? So let me show you my code. The code you will get would be super clean, so don't worry about it. So this is how I was thinking. This is how I was creating the mental map of the dynamic programming during the contest. This tells if first element is taken. Let's check this. This is for increasing, right? Strictly increasing. Di. Right. So again, this is I, the current index, the element we are filling. Previous element, sum. This status basically is nothing but status is yeah. So this status is nothing but our boundary, right? Boundary, what bound is it, like clashing with our boundary or not, right? This still checks if it's still increasing or decreasing, right? Strictly, right? And this str tells us if it's started or not. This L and R are the numbers, and N is total number of digits we have to calculate, right? And at finally we check what we check. If strictly is equal to 1, that means all the numbers are strictly, all the digits actually are strictly increasing, right? Let's actually remove the comments. These are for my debugging purposes. Yeah. So this def is where I'm actually storing the pre-calculating if it's all good or not. If it's good, if the sum is good, or it's strictly increasing or decreasing, that means we are going to return 1 here. That means this element is going to contribute into the fancy number, right? So this is finally what we check, and then this is what we are checking here. If this state already exists, return this. This is actually this is our superpower, right? If we have already calculated this state, then we are going to return this. Now this is where we calculate our range, right? This LL tells us what numbers we can include from 0 to 9, what digit we can use from 0 to 9. If this CN is basically calculating the number that occurred at the position of L and R. That is basically, for example, when we are at this position, this X position, this 2 and 3, this 2 is saved in TL, temporary L, and this 3 is saved in TR, right? This position, the value of this position at L and R, right? This is what we are storing in TL and TR. This is its implementation, right? I'm basically calculating it from last what element that we have to consider, and then we are just subtracting and taking calculating TL and TR, and then we check if boundary is equal to 3. That means that we have to satisfy both the conditions, check for both conditions. That means we start from TL and ends from N till TR. This is what we did here. This is LTL and this is our TR. We started from here and ended here. And similarly for boundary 2 and boundary 1 we are calculating it, and then here is our answer, right? And answer, how are we calculating it? If is our boundary is 3, right? This P boundary is our boundary that we will have for our next recursion or our next stack that we are pushing our recursion, our function basically. So this answer is how we are calculating our answer. This adds this basically I'm calling our recursion again or our function again. For next element, our previous element is PRI. PRI is J. Basically this we fill from LL to RR, right? So this would be some range of digits, right? Some range of it, right? So we check for each J. J is what we are filling, right? J would be our previous element. But if we haven't started it yet, right, that means our previous element would be -1, right? If J is equal to 0, that we the current element is 0 and we haven't started yet, that means previous is equal to -1. This is how STR is helping us, right? STR tells us if we haven't started or not, and then we are just adding J to our sum. This P boundary tells us what has our boundary condition updated or not. So this is how we are updating our boundary. If it was 3, that means both L and R, the previous elements of L and R are matching, right? If J is equal to TL and J is equal to TR, that means it's still matching, right? That means the boundary remains 3. If it's matching with L, that means boundary is equal to 1, otherwise it's going to be 2. And if it's not matching with N1, it's going to be 0. This is how we are updating our boundary. And similarly, if boundary was 2 and the element we are choosing again matches with the element at R, the boundary remains same. Similarly here too, otherwise the boundary is equal to 0, right? The boundary condition basically. And here we check if it's still strictly increasing or not, right? So this PR less than J checks if the current element is greater or not. This PR would be either be -1 if we haven't started the element, right? Otherwise it would be some number. So we are basically doing this, and here we check if we have started or not, right? So if J is greater than 0, that means we have filled some number and we have started, otherwise, or we have already started and the correct number is 0, either condition, and L, R and N. And similarly here we are going to just return our answer, right? Here this PR may be negative, right? Initial number we are taking as -1, right? If we are taking initial number 0 and J is equal to 0, this is going to fail here, right? So this is how we how are we doing it? So this is for strictly increasing, right? And here we can also here we are doing it for strictly decreasing. Only thing that is different in both the arrays is here what I'm doing is I'm checking if it's strictly decreasing. Also I've already checked if its sum is strictly decreasing or increasing, right? If I have already checked it here, right? So I'm omitting it here, so we only calculate it once, and then I'm going to return 1 here, otherwise I'm going to return 0. And the only condition we are in, that is different in both the arrays is this, right? Because here we need to check if it's decreasing. We have to compare if the current element is less than the previous element, right? So this is how we are doing it. So this entire function I'm pre-calculating it. The def is basically defined or predefined numbers. We are calculating for all 170 numbers if it's all if it's fancy or not, right? So we are just making the number, we are pushing all the digits to a vector, we are reversing the vector, and we are checking if it's increasing or decreasing or not. If it's not increasing, neither decreasing, if it's strictly increasing and strictly decreasing, that means that we are making it true. That means it's a fancy number, right? Here we are just putting -1 to each place in our dynamic programming vector, right? And here this n is basically we are calculating how many digits we have, and this we are doing our final answer, calculating a final answer, returning it, right? So this time complexity would be O of n. If you calculate how many numbers, if you multiply each of them, it would be around 5 into 2 is 10, 20. This is around 100. So we got 3, 10 is power 3, 4, 5, around that, 5 or 6, right? So this is how I did it. So yeah, let's end the stream. Hope you guys love the problems. If you have any doubt, if you still have any doubt, you can actually ping me out in the comments. I will be actively watching it. Do like and do subscribe. I hope I'm writing. Yeah, it right, and yeah, let's end the stream.